This is my Math 229 review of sections 4.1 and 4.2. We're going to look at the graphs of y equals sine x and y equals cosine x. So we're going to start first with y equals sine x. The most important part that you need to know about y equals sine x is that we're going to have 5 cut points. And those cut points are when x is 0, pi halves, pi, 3 pi halves, and 2 pi. So think of this as a horizontal xy table. All right, so basically every pi halves we're going to cut the graph. All right, dy values. Well, the sine of 0 is 0. The sine of pi halves is 1. The sine of pi is 0. The sine of 3 pi halves is -1. And the sine of 2 pi is 0. So the sine graph always goes 0, 1, 0, -1, 0. All right, here's how I graph it. And I don't particularly graph it to scale. I make one mark, and that'll be my distance that is pi halves. Since I'm cutting it every pi halves, I'm going to repeat that distance 4 times. So this will be pi, 3 pi halves, 2 pi. All right, now I have a height or range of values of -1 to 1. So I'll come over here, mark 1, mark -1, and then plot my 5 points. Connecting the dots. There we go. That is my sine graph. It got a little pointy in here. It should be a little bit more rounded, but hopefully you get the gist of it. All right, some facts. The domain. So I can actually keep graphing this forever and ever and ever. It never stops, but this is just one cycle or one period of it. So what I'm going to have here is my domain is -infinity to infinity, so I can actually plug in anything I want. The range means the y values, and the y values go from a low of -1 to a high of 1. All right, and as I said just a moment ago, it has a period of 2 pi. That means that it takes 2 pi to cycle through, and then it'll keep repeating. And then it has an amplitude. That means how tall it is. Has an amplitude of 1. Sometimes people think it has an amplitude of 2 because the total distance is from 1 to -1, but it really is talking about from this horizontal piece here that I go up 1 or down 1. So the amplitude is 1. Okay, we're going to repeat the same idea for cosine of x. All right, we're actually going to have the same 5 cut points. So I'm going to have 0, pi halves, pi, 3 pi halves, and 2 pi. But this time, when I plug in the cosine of 0 is 1. The cosine of pi halves is 0. Then I have -1, 0, and 1. All right, just as I did before with sine, I'm going to eyeball where pi halves is. And I'm going to keep making those tick marks so that I have a total of 5 cuts. Pi, 3 pi halves, 2 pi. Okay, and then we're going to have a height of 1, a low of -1. And here we go. And it's going to be close. I'm going to run into my table. But here's the graph of cosine. All right. Here's the good news. All these facts that we wrote down for sine are actually the same for cosine. So it also has a domain of -infinity to infinity, a range of -1 to 1, including the ends, a period of 2 pi, and an amplitude of 1. So this goes for both graphs. The only real difference is that the sine starts at 0, 0, 1, 0, -1, 0. And the cosine goes 1, 0, -1, 0, 1. Got it? All right, now, the first thing that we try and change is the amplitude. So that means the wave height. So what I have here is anytime you have a coefficient, that coefficient is going to change the wave height. So if I had, for example, 2 sine x if I had a half sine x or any number. Some of you might be thinking, why is she choosing only evens? All right, my favorite number is 17. No joke, it is. Whatever that coefficient is what changes the amplitude. Okay, so what that means then is instead of going from 0, 1, 0, negative 1, 0, what would happen down here, so I make some room. Okay. My y. Okay. Instead of going 0, 1, negative 1, 0, it would go 0, a, 0, negative a, 0. I ran out of room. And the cut points, sorry, are 0, pi halves, pi, 3 pi halves, and 2 pi. Okay, let's see if I can do a little bit better over here with cosine. Again, when you have a coefficient, no matter what that coefficient is, if I had 3 cosine x, 1/4 cosine x, all that coefficient does is change how high it goes. So our chart is right here for cosine. It goes 1, 0, negative 1, 0, 1. What it would do down here, it'd go a, 0, negative a, 0, a, with the same original cut points. All right, awesome. I hope this helps. By the way, I'm only focusing on A being positive. If A is negative, it actually does something different. It actually causes a reflection, and that will be my next video. All right, hope this helps. Good luck.